In the mid-1950s, with development of the intercontinental ballistic missile, an entirely new element was added to the strategic offensive situation. The potential seriousness of the threat posed by the nuclear-armed ICBM prompted planners to address a challenging question. Could a means be found to counter this new weapon? The Army and several key defense contractors had a decade of experience in developing and operating air defense missile systems. Since air defense technology appeared to be a promising starting point from which to pursue a solution to the ballistic missile threat, the Army was given primary responsibility for this investigation. Research into this new field, ballistic missile defense, began in 1955 with contract award from Redstone Arsenal for an effort called the Nike II Air Defense Study. Based on results of the study, the first BMD program office, the Redstone Anti-Missile Missile Systems Office, or RAMSO, was established in 1957. It was the forerunner of the various organizations which have continued the work, down to the present U.S. Army Strategic Defense Command. In that same year, R&D was begun on the first proposed BMD system, which was named Nike Zeus. By 1962, the Zeus effort was able to demonstrate solid evidence that defense against ballistic missiles was possible. The event was the first successful intercept of an ICBM reentry vehicle. In this demonstration, a target ICBM was launched from Vandenberg Air Force Base, California, to Kwajalein Missile Range, some 4,300 miles away in the Pacific. On Kwajalein, the Zeus radars, after acquiring the target, had less than 3 minutes to track it, determine a point of intercept, and launch the interceptor missile. The white spot is the target. Zeus will come in from the left. A spotting charge was carried aboard Zeus's third stage. The photography is repeated. An important point here is how the terms successful intercept were defined at the time. The intercept missile, capable of carrying a nuclear warhead, needed to come only close enough to the reentry vehicle so that it would have been within the nuclear weapon's lethal radius. Not long after this test, Zeus was used in an early demonstration of Army BMD technology's potential for space applications. In 1963, a Zeus missile was guided close enough to an actual satellite to establish its capability for nuclear interception of satellites. As a result, Zeus was the first operational ASAT weapon and was kept available for this role until 1964. The decision was made, however, not to deploy a Nike Zeus BMD system. The ICBM threat was already becoming more sophisticated and demanded more sophisticated methods of defense. Therefore, the Nike X project was begun. It was, among other things, one of the first efforts to develop phased array or electronically steered radars, and introduced the concept of a layered defense, that is, different interceptors for different altitudes of operation. In 1967, the Johnson administration announced the decision to build and deploy a BMD system, named Sentinel. It would provide light area defense of major urban and industrial areas across the country. Sentinel was intended primarily to counter a potential missile threat from the People's Republic of China. 17 defensive sites were proposed. Meanwhile, the magnitude to which the BMD effort had grown, and the hundreds of government personnel at work on it, made it clear that a permanent home, specifically for the project, was needed. A facility was built in Huntsville's Research Park near Redstone Arsenal, and by early 1969, the move into the new building had been accomplished. Under President Nixon's administration, the Sentinel concept was reoriented. The same basic components would be developed and deployed, but to defend part of the U.S. ICBM force rather than urban areas. The system would be called Safeguard. The success of Safeguard system development activities convinced the Soviets of U.S. seriousness about ballistic missile defense. As a result, the Safeguard program was a key factor in making possible signing of the ABM Treaty in 1972. The original Safeguard proposal called for 12 sites, but as treaty and other constraints came into play, the system ultimately deployed consisted of one site in North Dakota, which was completed in 1975. There were 4 primary components: the long-range perimeter acquisition radar, the shorter-range missile site radar, the long-range Spartan interceptor missile, and the Sprint missile, designed to intercept reentry vehicles at relatively close range. Partly because of limitations imposed by the treaty, however, Congress decided to inactivate Safeguard in 1976, after only a few months' operation. The decision was based on a congressional determination that the treaty-limited system could not provide a defense effective enough to justify the cost of continued operation. Concurrently with these Safeguard developments, an important administrative milestone occurred in 1974, when the Army's BMD effort was reorganized under a single office. The new program manager was placed in charge of the BMD organization, which consisted of the BMD Systems Command, BIMSCOM, the BMD Advanced Technology Center, and the Kwajalein Missile Range. Even as Safeguard was being inactivated, progress toward the next generation of BMD technology was well underway. Since 1971, the Site Defense Program had been exploring methods of effectively countering an increasingly formidable ICBM threat, larger and more sophisticated than Safeguard was designed to handle. The post-Safeguard BMD program can be described as a bits and pieces effort. Since Congress had limited the program to working on components and technologies rather than whole systems. In spite of this limitation during the latter half of the 1970s, ambitious research projects were conducted. For instance, the Systems Technology Program within BIMSCOM was highly productive in terms of resolving complex technical issues, validating nearly 10 years of BMD technology advances and reducing the lead time for deployment of a system if the decision to do so was made. Likewise, the BMD Advanced Technology Center was conducting a diverse array of projects, such as the Designating Optical Tracker program, which used rocket-lofted optical sensors to observe reentry vehicles in flight. This effort greatly expanded our knowledge about potential applications of optical sensor technology for defense against ballistic missiles. Late in 1979, program emphasis turned to developing options for defense of the new U.S. ICBM MX, later named Peacekeeper, in the various basing modes proposed. A key undertaking during this phase was initially called Low Altitude Defense, or LOAD. In 1982, it was renamed the Sentry Project. Sentry focused on component development in support of a candidate BMD system for defense of U.S. ICBMs or other hardened targets. Before being discontinued in early 1983, Sentry showed the significant advances which the BMD program had made in areas such as miniaturization, component hardening, and cost reduction. Meanwhile, President Reagan had launched a major new effort, emphasizing research into methods of defending not only hard targets, but people in cities from strategic nuclear missiles. This effort is the Strategic Defense Initiative, or SDI. In mid-1984, as the SDI was gaining full momentum, the BMD organization contributed dramatic evidence of its progress toward the type of non-nuclear defense envisioned by the President. The event was a flight in the Homing Overlay Experiment, or HO. As in the 1962 Nike Zeus intercept, an ICBM fired from California supplied a target RV for the experiment. And the HO flight vehicle was launched from Kwajalein Missile Range. But there the similarity ended. The whole vehicle, instead of being guided by ground-based radars and data processors, carried an onboard optical sensor and data processors for guidance and control. Using these, it acquired the speeding target RV, tracked it, and homed in for the kill, which it accomplished by direct impact. The target was smashed to bits, as revealed in a slow-motion replay of tracking camera footage. This brief history helps explain why the Army was called on to carry out significant responsibilities in the SDI program. To reflect this close relationship with SDI, in 1985, the Ballistic Missile Defense Organization was renamed the U.S. Army Strategic Defense Command. This was followed by a complete organizational realignment. The changes again underlined the Army's long-term commitment to eliminating the threat of nuclear war.